Hey everyone, welcome back to the channel. Today we are going to be diving into something that I'm really excited about. So we are going to be building a real-time chat application in Java using Spring Boot, WebSockets and Timeleaf. I have named this as SocketTalk, and the idea is to show you how to create a chat app that feels modern and responsive with a UI inspired by Telegram. In this video, I'll walk you through the code step by step, explain how WebSocket handles real-time communication, and of course, we will end up with a live demo so you can see WebSocket and our app SocketTalk in action. So let's get started and build this from the ground up. Alright, so before we jump into the code, let's take a moment to understand these key concepts behind the demo. If you're new to real-time messaging or WebSocket based systems, this will help you follow along with full confidence. Most of the web runs on HTTP protocol, the classic request and response model. The browser asks for something, the server replies, and the connection closes. Deal done. That's great for loading pages or submitting forms, but not so great when you need live updates or two-way communication. For things like real-time file transfer or instant sync, we need something more persistent. Developers have tried to work around HTTP's limitation using polling. In short, polling, the client keeps asking the server, like, hey, anything new? Any updates? Which wastes bandwidth and server resources as well. Long polling is a bit smarter, where the client asks once and waits until the server has something to say. It's better, but still relies on repeated reconnections and isn't really real time. So WebSockets solve this problem. They start as an HTTP request initially, but then upgrade to a persistent TCP connection. That means that both the client and the server can send data whenever they want. There is no need to wait for a request. It is full duplex, low latency, and perfect for our use case, which is sending binary files encoded as text. Now let's talk about STOMP. STOMP is simple text-oriented messaging protocol. Think of it as a tiny standard that sits on top of our WebSocket connection and turns that raw socket into a lightweight message bus. Instead of sending arbitrary bytes and inventing your own rules, STOMP gives you frames like connect, send, and subscribe, so both the client and server speaks the same language. This is especially useful in Spring because Spring messaging maps STOMP frames directly to controller methods or endpoints. So you get readable messages, topic based routing, and an easy part to add broker backed durability later. For our demo, we will be using STOMP with SockJS, so browsers get fallback, and we will send base64 payloads inside STOMP send frames. So now it is time to set up our project. So I have moved to Spring Initializer and I'm going to name it as com.chat application, and I'll give it the name as Socket Talk. And then I'm going to keep the Java version as 21 and the configuration file as properties. And this is pretty much okay. Now I'm going to add some dependencies that we are going to need. I'm going to need, first of all, web, because this is going to be a web service. Then I'm going to actually need WebSocket. Then I'm going to also need uh, time leaf because I'm going to make use of templates for the chat application. We are going to combine either Tailwind or Bootstrap to make it more attractive, but we will be rendering it with the server rendered format only. So I'm going to make use of Timely as well. You can go and add DevTools or Lombok or whatever you need for your convenience, but I'm going to keep it as is, and I'm going to revisit and add more dependencies if I need them. So I'm going to just click on generate, and I'm going to select the location real quick. Yeah, I'm going to save it and I'm going to extract it in this location, and I'm going to get rid of this zip file. And now I'm going to open this folder in IntelliJ IDEA as project. It's going to load all the files, and then it is going to load all the dependencies that we need. It is going to take a minute to do all that. So this is pretty much okay, built out successfully. There were no problems in this. So now I can go ahead and do the development for this application. Okay, so in the starting, what we need to do is we need to create one configuration file for our WebSocket and the message broking. So I've created a package called config, and inside it, I'm going to just create a Java class, and I'm going to call it as WebSocket config. And this class is going to actually implement WebSocket message broker configurer. Now, talking about this particular interface, so it actually provides us a lot of methods that will help us with STOMP and WebSocket message mapping. So first, I'll just annotate it with @configuration, since this is a configuration file, and I'm also going to annotate it with enable WebSocket message broker. So this will enable message broking in our Spring Boot project. So what do you mean by message broking? What is a message broker? And what do you mean by the producer consumer model? So let us imagine that you write a letter and drop it at the post office. Now, the post office doesn't care about who wrote it, it just makes sure that it is delivered to the right person. So, in this example, you are the producer, and the post office is the broker, obviously. And the person that you write the letter to is going to be your consumer. Now, in a real world scenario, there can be multiple consumers to what the producer is sending. So, in short, a message broker is the middleman that safely delivers information between different apps or services. And message broking is the process of delivering information safely from one end to another end. Let's understand this with the help of a simple real world scenario. Let's check out the order flow of a particular e-commerce app. Here, an e-commerce app sends an order placed event. So the app itself is the producer, and the broker receives the event, validates it, and routes it. There are various consumers for it. First one to consider is the inventory service that will update the stock. Then there is the payment service, which is going to process the entire transaction. Then there is also the notification service, which is going to send confirmation to the customer that his or her order has been placed. All these consumers act independently, but the broker ensures they get the right message. Then what I need to do is I need to actually generate some overridden methods. So I'm going to use IntelliJ to do that. First I need is the register stomp endpoints, and then I need a configure message broker method, and I'm going to click on OK. So IntelliJ will actually provide the implementation for this as well, but I don't want these implementations because I have to write my own. So I'm going to remove this first. Then what I need to do is I need to enter a registry, and in this registry I will add an endpoint wherein we will be receiving and we will be sending message from. So I'm going to call it as /chat, and I'm going to then add another method, that cloud origins. So herein we will actually accept the messages coming from. So I'm going to actually add the URL for my front end. And since we are making use of Thymeleaf over here, the URL for front end is going to be the same as our backend. So this is going to be HTTP, not HTTP / localhost :8080. After that, I am also going to add this with SockJS. Now, adding SockJS means that you are actually including all the browser support for this. So even if you have like a really old browser or a browser that doesn't really support WebSockets, it will support WebSocket now with the help of SockJS. Now, I'll also change the implementation for this overridden method here. Now, since we added the registry for /chat endpoint, I'm going to then add registry, and I'm going to enable simple broker here, and I'm going to add the destination prefix as /topic. Then I'll add the entire application destination prefix, and I'm going to simply call it as app. So this basically means that whatever our request will have this prefix /app. So this will actually help us create the controller. Then since we have done the configuration over here, this is what we needed. I'm going to now create another package, and I'm going to call it as controller. Now inside this controller package, what I'm going to do is I'm going to create another class, and I'm going to call it as chat controller. Now, since this is a controller, I'm going to annotate it with @controller annotation. Simple MVC, we are going to annotate with @controller. We are not actually creating a REST endpoint. That is why I have not added @REST controller over here. Then after that, what I'm going to do is I'm going to start with a method. Actually, I'm going to call it as send message. So I'm going to call it as send message, and this method is going to return actually a model to me or an object to me, which I'm going to call it as chat message. Now I realize I haven't already created this chat message, so let's do one thing. Let's create a package and call it as model. Now inside this model package, I'm going to create the Java class and call it as chat message. And inside this chat message, what I'm going to add some fields. I'm going to add private long ID for ID. Then I'm going to also add a sender. So this field will actually contain the name for the sender. So this will be of type string. After that, I'm going to contain the message that we are sending. So this will also be of type string. So I'm calling it as content. Now this thing we do not need to add it as an entity because we are not mapping it with any of our object or database table. So we are not going to annotate it with entity, but we are going to need the getters and setters and a constructor for this, since we are going to create an object off of it. So I'm going to click on generate. I'm going to click on constructor, but select none. So this has provided us with a constructor, and after that I'm going to actually create actually generate the getters and setters. So I'm going to select all here and click on OK. This is done, but we are getting a problem over here that okay, we haven't yet written the code for this. That is why it is showing an error. Let us continue with our work here then. So this method will also actually accept an object of chat message. So I'm going to pass the message over here, and inside this method I'm going to return the message itself. So this is done. Now I need to do a couple of things over here. I need to annotate this method with @message mapping annotation. Then I will also be needing an annotation send to, and this annotation, okay, I need to import it. So let's import class. So this annotation will actually consist of a slash topic slash messages. So this will actually be the place where we will be getting the messages for the particular topic, and after the client actually subscribes to that particular topic, and all the messages will be shown to that client. Then I'll need to add another method over here that will be returning a string value to us, and I'm going to just call it as chat, and this is just going to return chat to us, since this is a Spring MVC controller, and I'm going to annotate it with get mapping annotation. So before building and testing this project, let us actually revisit what we are doing in the controller layer. So as I already mentioned that this @controller annotation tells the framework that this class chat controller is a controller. It is a web MVC controller. So this controller, like any other controller, will handle the incoming requests for us. And inside this class, you see that there is a method topped up with the message mapping annotation, and this annotation maps incoming messages from the WebSocket to this method send message when the destination is slash send message. And then talking about this send to annotation, this annotation says that after executing the send message method, the result should be sent to topic slash messages. Anyone subscribed to this topic will get the messages. Moving ahead to another to the method itself, like this method will take an argument of type chat message, which is basically our model, and this model includes an ID and the name of the sender and the content that the sender has sent. uh, it will take this chat message as input and simply return it. Then after that we have another method which is topped up with the get mapping annotation. This annotation maps http get request to slash chat to this method, and what this method is actually doing is it is returning the string chat when someone makes a request to slash chat. I think I have missed a slash over here. Okay, so let's save this for now, and it is a simple endpoint. So if you summarize the entire flow, so when a message comes to send message via WebSocket, send message method is called, and the message is returned and broadcast to everyone subscribed to slash topic slash messages, and a get request to slash chat returns the string chat. So I'll just go ahead and build this now, and this will take a few moments to build, and then after that I'm going to just run this program. And after that I'll actually open two of my browsers, and I'll just open localhost 8080 with it. I've already added one file for the front end chat.html. This contains all the code, and we are making use of some CSS, and we are making use of some JavaScript functions to actually connect and then update the participants and show messages. That kind of functionality we have added. So as you can see, that function connect will actually create a instance of SockJS with slash chat mapping. And once this is done, we will be subscribing to this slash topic slash messages, and we will be calling the function message output over here. And then send message will be sending the message, pretty evident from the name. And from show messages message, we are actually going to do one thing. We will be checking if we have sent or received the message. And again, if a particular sender is sending the message, it will not be reflected as his name. Instead, it will show you. So it makes a bit of personalization over there. And I've actually added one more like sidebar thing, and therein we can see all the participants of that particular chat room. So that list will be stored over here, and it will be updated from time to time when a new message or a new client is added. And this is one pretty small script that we have added just to basically take input on enter, on pressing the key enter. As you can see that I am calling the event listener over here, and for key I'm using enter. So this is pretty much it for the front end. And let us actually go ahead. Okay, this is showing me error because this is not just 8080, is on the endpoint slash chat. So as you can see that I'm being prompted to enter my name to join the chat room. This is because I've added this prompt over here. So it actually asks you to enter your name. I think I have added this multiple times, so that is why this message is being overridden. Let me check once. Yeah, enter to join the chat room. Yeah, so this function is getting overridden. I will uh, I'll remove this, or I'll see this later, but let's actually open another browser with the same URL. So let me actually open this one up here and this side, and I'm going to paste it here. Let's actually open another of a different browser actually. So I'm opening Brave over here. Let's open these like that. So I'm going to paste it in this chat box. So for this, I don't think I have added a name. So add a name here. I'll add it as Suyash. In this one, I'll add it as Aryan. In this one, I'm going to add it as Leo. So if I type a message like hi and I'll click on send, it will be showing participants as Suyash, and I'll see this message as hi from the window of Aryan. But from my own window, I'll see that I have typed hi. So you hi. Then after that, from Leo, from Aryan, I'll actually be typing hello as a response to my own message. So instead of clicking on send, I'm just pressing enter. That will be shown as well. So as you can see that for these two people, for me and Aryan, I'm seeing messages on the alternate side, just like you see in WhatsApp and Telegram and any other messaging app. And for the third person, it is showing on the same side because that is there. So when I type in hey from this side, I'll be seeing this a different place. So that kind of interactive platform or real-time communication we have built in the front end. And if you actually reload this any of these pages, your participant will actually be lost. If you have to continue, you will have to give another name. So in this, I can enter as Sam, and when I type in hi, I'll be entering as a different person or participant in this chat room. And that's it. We have built SocketTalk, a real-time chat app powered by Spring Boot and WebSockets with a clean front end. We have covered how to set up the project, wire up WebSocket communication, and design a simple but effective UI. Hopefully, give you a clear idea of how you can integrate real-time messaging into your own projects. As usual, the repository for this project is mentioned down in the description. If you found this helpful, don't forget to hit the like button, subscribe for more such content, and drop a comment if you'd like to see me expand this project. Maybe add a feature like file sharing, add authentications, or even a mobile friendly UI. Thanks for watching, and I'll see you in the next one.